The Atlas robot, created by Boston Dynamics, stands as one of the most remarkable and advanced humanoid robots ever built. It represents a bold leap toward a future where machines and humans may one day work side by side in environments once considered impossible for robots to navigate. Atlas is not just a research project but a symbol of how far robotic engineering, artificial intelligence, and mechanical design have evolved in the 21st century. Designed to replicate human movement, agility, and balance, Atlas has become the global face of humanoid robotics, capable of walking, running, jumping, and performing complex gymnastic routines with precision and control that seem almost alive. Its creation reflects Boston Dynamics' ongoing pursuit to understand and replicate the principles of dynamic mobility in machines, a goal that has captivated scientists and engineers for decades. Atlas was first introduced to the public in 2013, developed under the sponsorship of the Defense Advanced Research Projects Agency, DARPA. The original purpose of Atlas was to assist in search and rescue operations during disasters, where human access might be too dangerous or impossible. Imagine a robot able to climb debris, open doors, and navigate rubble while delivering supplies or rescuing survivors. That was the vision that drove its development. Over the years, Boston Dynamics transformed that early prototype into a breathtakingly agile, electrically powered machine capable of performing movements that no other humanoid robot could match. Through years of continuous iteration, Atlas evolved from a heavy, hydraulically powered machine tethered to external equipment into a fully untethered, self-balancing, battery-powered marvel. Standing at about 1.5 meters, 5 feet tall and weighing roughly 89 kilograms, 196 pounds, Atlas is proportioned very much like a fit adult human. Its sleek metallic frame conceals some of the most sophisticated robotic systems ever created. The robot's structure is made of lightweight aluminum and titanium, allowing for both durability and agility. The joints are powered by hydraulic actuators that provide smooth, lifelike motion, and the head is equipped with a suite of stereo cameras and depth sensors that give Atlas a three-dimensional view of its surroundings. These sensors feed real-time data to its onboard computer, allowing it to make micro-adjustments every millisecond to maintain balance and orientation. This is what enables Atlas to run, jump across gaps, or recover gracefully when pushed, abilities that make it appear almost conscious of its movements. The heart of Atlas's design philosophy lies in dynamic motion control. Traditional robots were built to move in predictable, rigid patterns, lifting an arm, turning a joint, or walking on flat surfaces with pre-programmed steps. Atlas breaks that mold entirely. It doesn't simply follow static scripts. It calculates balance, force, and motion dynamically, similar to how humans unconsciously adjust their posture when walking on uneven ground. For example, when Atlas jumps onto a platform, it calculates the impact force and immediately adjusts its joints to stabilize itself. This dynamic adaptation makes it incredibly robust in complex environments, from climbing stairs and jumping onto obstacles to performing backflips and parkour routines. Boston Dynamics achieved these capabilities through years of research in robotic control systems and machine learning algorithms. Atlas's movements are controlled by a real-time computer system that analyzes the physics of every motion. Using powerful onboard processors, it calculates torque, speed, and trajectory dozens of times per second. The robot's control software predicts the consequences of each movement and compensates instantly, creating the illusion of fluid motion. Behind the scenes, these movements require thousands of mathematical calculations, a fusion of physics, kinematics, and AI working together seamlessly. The company's engineers often describe Atlas as a machine that learns to move like a human, not by imitation alone but through the precise application of mathematical models of balance and inertia. One of the most visually striking demonstrations of Atlas's capabilities came in 2018, when Boston Dynamics released a video showing the robot running smoothly across a grassy field and effortlessly jumping onto wooden platforms. The video went viral, with millions of viewers astonished by how naturally Atlas moved. In subsequent years, the robot's abilities expanded dramatically. It learned to do backflips, jump spins, and complex gymnastics sequences. A particularly famous demonstration in 2021 showed two Atlas robots dancing in perfect rhythm to music, a feat that required precise synchronization, balance control, and timing. Each footstep, twist, and arm movement was calculated in real time, demonstrating a level of mechanical coordination once thought impossible. Although Atlas's movements may appear playful or entertaining, every routine Boston Dynamics design serves a deeper research purpose. Dancing and parkour may seem like fun, but they actually push the limits of what balance control and dynamic movement can achieve. Each jump and turn helps engineers improve the robot's algorithms for coordination and reaction time, which could later be applied to practical tasks such as rescue missions, industrial work, or exploration of hazardous environments. By testing Atlas in extreme movement scenarios, the team learns how to make machines that are more resilient, responsive, and adaptable to real-world challenges. The power system that drives Atlas is another technological marvel. The robot runs on a custom-built battery pack that provides energy to dozens of hydraulic actuators, which serve as the robot's muscles. Each actuator is responsible for moving a specific joint, from the shoulders and hips to the knees and ankles. This system allows for a range of motion very similar to that of a human being. Unlike traditional robots that rely on electric motors alone, the hydraulic system provides immense strength and smoothness, allowing Atlas to lift heavy objects, push doors, or leap off platforms with impressive power. The internal cooling system keeps the hydraulics at optimal temperatures even during demanding movements, ensuring the robot remains stable and precise under stress. Atlas's head and sensory system serve as its eyes and brain. Equipped with stereo vision cameras, lidar sensors, and depth perception systems, it can map its environment in real time. These sensors enable Atlas to recognize objects, estimate distances, and plan its steps with precision. For example, when walking through a cluttered environment, the robot identifies obstacles and determines the safest route forward, a complex process that requires continuous calculation and coordination. This level of perception and adaptability makes Atlas not just a machine that moves, but a robot that thinks about movement in the way a living creature might. The software behind Atlas is built on advanced algorithms that integrate perception, control, and planning.